3.4, just really briefly, and I mean like one page really briefly, here on page 102, just mentions what happens at the limits of our variable types. So as not to beleaguer the point, we are using a short int here in the example that you can see in program 3-7 on page 102. What we are suggesting is that a short int has a maximum total value on the positive side. So it's got a maximum negative value and a maximum total positive value. So for that short int, its maximum positive value is 32,767. There's a reason for that we don't need to go into here. So what happens when I add 1 to 32,767? It does what is called wrap. So short ints go from negative 32,768 to positive 32,767. If you'll notice, there's a little bit of a disagreement there. This side of my equation goes, it's this side for you guys, I believe. No, it's this side. This side of the equation says it ends in an 8. This side of that, not equation, but spectrum ends in a 7. Why is there that discontinuity there? Because 0 is a positive number in that case, right? Because it's not negative, so it must be positive. So that's taking the 1 away from our total maximum upper limit. So if I have this short int and its value is already the maximum value that that short int can take, that is 32,767, and I add 1, it does what's called wrap. It wraps all the way around and it goes to negative 32,768. If I subtract 1 from negative 32,768, it wraps again. In this case, the other way around to positive 32,767. So the boundaries are important to be aware of because there are going to be times where you have you have chosen a variable type and you are going to get values that represent their maximum total values that you can use, short int in this case. So it would be better in this case to be able to use int because that's going to give us a vastly larger number of integer values to be able to use. There are times where you're going to run out of float, and those are where we have overflow and underflow. So what essentially that means is the data you're looking to put in there is too big for the container and they're going to overflow, or too small for that container, so it cannot be contained therein. So they are things to be aware of. We probably will not have you encounter those limits here in our version of this class for C++. It is also nearly impossible for me to tell you how to expect an overflow, an underflow, or how to look for that wrapped number, because depending on the system that you are running this in, we're running it in Replit, we are relying on G++, we are relying on Replit to be able to run this for us. But if I was to run this in Xcode, the conditions might be different. If I was to run this in Visual Studio Code, the conditions might be different. If I'm going over to an older version, let's say of Eclipse that has an older version, let's say of C++, the rules there are going to be different. So there's no way I can tell you what to look for by like writing it on a hat. There's just too many variables there to be consistent. So it's worth knowing that these things happen. It's worth knowing what happens when these conditions are met, but it's very, very difficult to actually go through and detect when these happen. Better to know, hard to find.